A very warm welcome to all of you in today's session. I am Professor Muhammad Ahmad Qureshi, working as an assistant professor in Civil Engineering Department at R.N.G. Patel Institute of Technology, Bardoli. Today we will learn about mechanics of solid subject. Now, first of all, what do you mean by mechanics? Mechanics is nothing but branch of science which deals with the state of rest or motion of particles and bodies under the action of forces. Then we will further go to mechanics of rigid bodies. Mechanics of rigid bodies is nothing but engineering mechanics. In engineering mechanics, there are two sub-branches. First is statics and second is dynamics. Now, static is nothing but the bodies at rest position, and dynamics the bodies which are in motion. What is statics? Statics is nothing but it is the branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies at rest. And in case of dynamics, it is that branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies in motion. Here is the simple basic rule of static and dynamics. Static means simple, the body is at rest, and dynamic means the body is in motion. Further, dynamics has two sub-branches. First is kinetics and second is kinematics. What is kinetic? It is that branch of dynamics which deals with the bodies in motion due to the application of forces. Due to the application of forces. And what is kinematics? Kinematics is that branch of dynamics which deals with the bodies in motion without any reference to forces which are responsible for the motion. So, this is the simple branch of mechanics. Mechanics, it is nothing but a branch of science which deals with the state of rest or motion of particles and bodies under the action of forces. Further, engineering mechanics has two sub-branches, statics as well as dynamics. And what is static? It is that branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies at rest. And in dynamics, it is that branch of engineering mechanics which deals with the forces and their effects while acting upon the bodies in motion. Further, dynamics is classified into kinetics as well as kinematics. And in kinetics, it is that branch of dynamics which deals with the bodies in motion due to the application of forces. Means body and forces are responsible for the motion, whereas in kinematics deals with the bodies in motion without any reference to forces which are responsible for the motion. So now further we will go to some basic concepts that are used in engineering mechanics. So now first is space. What is space? Space is nothing but a region in all directions and contains everything within. For example, sun, stars, planets, etc. It is the unlimited expanse of physical dimension in which all material objects are located. Simple. Now, second definition, we will go for time. What is time? It is nothing but a measure of duration between successive events. Main word is this, between successive events. And we know that SI unit of time is nothing but second. Second is the SI unit of time. Third, third basic definition is matter. What is matter? Any substance which possess weight or occupies space is called matter. Now, next we will go for body. What is body? Body is nothing but the matter enclosed by a closed surface is called body. It is nothing but accumulation of large number of particles is known as body. Then next definition is inertia. Next definition is nothing but inertia. What is inertia? It is the property. Which property? By virtue of which a body offers resistance. A body offers resistance to any change of its state of rest or motion. Then next definition is nothing but of mass. What is mass? The quantity of matter. Most important thing, the quantity of matter contained by a body is known as mass of the body. Then rest. A body is said to be at rest if it does not change its position, if it does not change its position with respect to a reference point at different intervals of time is called a body at rest position. Then motion. Motion and rest both are vice versa to each other. A body is said to be in motion if, most important word, if it changes its position with reference to a reference point at different intervals of time. Example for rest is a car parked in a garage or a bike parked in a garage is known as at rest position, whereas in case of motion we can say a car moving on a road or a bike moving on a road is known as body in motion. Then next definition is of particle. What is particle? It is an idealized body, or we can say that it is an assumed body which may have negligible mass, which may have negligible mass and whose shape as well as size can be neglected. It is known as a particle. It is nothing but viewed as a mass point, or we can say that whose size does not affect its response to the forces acting on it. Next definition, rigid body. We have seen previously what do you mean by rest, what do you mean by motion. Similarly, rigid body. A body is said to be rigid if, most important point, or we can say that most important word, if the relative distance between the particles of the body remain same. Relative distance between the particles of the body remains same before as well as after the application of force or forces. And next is deformable body. A body is said to be deformable if its size and shape changes under the application of external force or forces. Then we can say that a body is in deformable condition. Next, we will go through the basic principles of mechanics. As we have studied in physics in standard 11th as well as in standard 12th, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, as well as Newton's law of gravitation. Similarly, parallelogram law of forces, principle of transmissibility, principle of superposition of forces. All these laws are equally important in principles of mechanics, or these are the basics law that will help for solving the problems in engineering mechanics. Now, we will go through first parallelogram law of forces. Parallelogram law of forces. It states that if two forces, suppose this is your P force and suppose this is your Q force. It states that if two forces, for example P force and Q force, acting simultaneously on a particle, suppose this is our particle and we have given the point O, be represented in magnitude and direction, be represented in magnitude and direction by the adjacent side of parallelogram, by the adjacent side of the parallelogram, then their resultant for P force as well as for Q force, both force have some common resultant, then their resultant may be represented in magnitude and direction by the diagonal, by the diagonal of the parallelogram which passes through their point of intersection. This is nothing but parallelogram law of forces. And the angle between P force and Q force is denoted by theta, whereas the angle between the resultant force and any of the forces is denoted by alpha. This is parallelogram law of forces. What it states? It states that two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of the parallelogram, then their resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through their point of intersection. So this is your first law, parallelogram law of forces. Now, second law is principle of superposition of forces. Suppose this is your one object. At this point, we give point A, and at this point, we name this point B. And a tensile force of 10 kilonewton is acting at point B. I am drawing the same figure as I plot earlier. This is your A point, this will be your B point, and same force P equals to 10 kilo Newton. Now I am adding, suppose this will be your T1, and P1. I am adding P2 force as 20 kilonewton at point A, which is nothing but a compressive force. And similarly, here I am adding P3 as 20 kilonewton. So, what does the principle of superposition of forces state? It states that if two equal, here I had add two equal 20 kilonewton, 20 kilonewton, opposite, both are in opposite nature, and collinear force means both forces are lying on the same line of action. If two equal 20-20, opposite and collinear forces are added or removed from the system, are added or removed from the system of forces, then there will be no change in the position of the body. Then there will be no change in the position of the body. Means though I am adding 20 kilonewton and 20 kilonewton as P2 and P3 forces, it will have no effect on this object or on this body. Now, third one is Newton's first law of motion. You had already studied Newton's first law of motion in physics. What it states? It states that every body continues in a state of rest or in uniform motion unless and until it is compelled to change that state by some external force. Then Newton's second law of motion. It is nothing but F equals to ma. What is Newton's second law of motion? The acceleration of a body is directly proportional to the impressed force and takes place in the direction in which the force acts. This is nothing but Newton's second law of motion. F is proportional to a. Further, F equals to ma. What is m? M is nothing but constant representing the mass of the body. Then you had also learned in physics Newton's third law of motion. It is simple. What is Newton's third law of motion? For every action there is an equal and opposite reaction. Always. For every action, there is always an equal and opposite reaction. Now, sixth principle of transmissibility. What is principle of transmissibility? It is nothing but a push force can be converted. A push force can be converted into a pull type force. If any force acts at any point on a rigid body, it may be considered to act at any other point on its line of action, provided the point is rigidly connected with the body. Simple. Suppose this is your body. I am applying the push force at body A. Then it will be easily converted into pull type of force. When will this condition will apply? If the point is rigidly connected with the body, then and then only principle of transmissibility is governed by the criteria. Now next, we all had learned fundamental units in physics in 11th as well as in 12th science. So first of all, we will go to fundamental units. Fundamental units. What do you mean by fundamental units? Basically, there are three fundamental quantities. Means all the physical quantities that are used in engineering mechanics are expressed in terms of three fundamental quantities. First is length, second is mass, and third is time. The units of these fundamental quantities are called fundamental units. The units of these fundamental quantities. Which fundamental quantities? Length, mass, time. The unit of all these fundamental quantities are known as fundamental units. And second is nothing but derived units. The units of some physical quantities, units of some physical quantities are derived from these basic fundamental units. Some physical quantities are derived from fundamental units. Such units are called derived units. For example, unit of area, unit of velocity, unit of acceleration. There are many other types, etc., are derived from fundamental units. Hence it is known as derived units. Then scalar quantity. What is scalar quantity? It is nothing but completely specified by its magnitude only. Most important word, only magnitude. Means a scalar quantity is the one which can be completely specified by its magnitude only. For example, length, distance, mass, energy. This all the parameters are completely specified by the magnitude only. Next, we have one more term, vector quantities. A vector quantity is one which requires magnitude and direction to completely specify it. In scalar quantities, all the quantities are completely specified by its magnitude only, whereas in vector quantities, it requires both magnitude as well as direction. For example, vector quantities, displacement, velocity, movement, these are given name as vector quantity because they requires magnitude as well as direction to completely specify it. Now we will go to some basics of forces. We can say in mechanics of solid chapter 2 coplanar concurrent forces, coplanar concurrent forces. Till now we have studied that what is force? Force is nothing but F equals to ma. But now we have to change our definition because entire mechanics of solid subject is based on forces. So now, first of all, what is force? Force is an agent which produces or tends to produce, or we may say that destroys or tends to destroy. What it produces or what it destroys, nothing but the motion of a body is known as force. And one most important thing, unit of force is Newton. And as we have studied earlier, vector quantity as well as scalar quantity, then what is force? Force is nothing but a vector quantity. Force is nothing but a vector quantity. Now, some basics characteristics of force. Characteristics of force. First characteristics, magnitude. In our numerical, in almost all the numericals, in entire statement, there are some words like 10 kilonewton, 20 kilonewton, 30 kilonewton, 40 kilonewton. What are these 10 kilonewton, 20 kilonewton, 40 kilonewton? This is nothing but a magnitude of force. The magnitude of force is written as 10 kilonewton, 20 kilonewton, 40 kilonewton, or it may be any one. So this is one of the characteristics, that is magnitude. Now second one is direction. What is direction? It may be along OX or OY or in any direction, or it may be towards south, towards east. It may be at 30 degree or 40 degree west of north or east of south or in any direction. Then third characteristic is nature. Now the nature of force may be tensile or it may be compressive. Basically, just keep in your mind that push force is known as compressive force. Compressive force is nothing but a push force, whereas tensile force is nothing but a pull force. This both word will help you a lot in solving your engineering problems. Then the fourth characteristic is point of application. What is point of application? It is nothing but the point. Suppose this is your point, and at this point I am applying some force. Then this point is known as point of application. The point at which the forces acts on the body is called point of application. In next lecture, we will study some system of forces as well as we will solve the example related to coplanar concurrent forces. Thank you very much.